Hello everyone. Am I audible?
Yes, you are audible.
Okay, good. I have already present my screen and right like by now it is showing over to your screen. So today we have very low participants. So let's continue and wait as they join us. So we will continue our today's session. VPC, we have studied about VPC. I hope all of you guys are practicing EC2 instances and okay, so we were talking about VPCs. We have seen many things in VPCs. This is our virtual network we create over to our cloud, and we have seen that we have to give it a CDR block in which we will creating our configuration and what kind of configuration we can do. We can create different subnets, public and private, and VPC with single public subnet. We have seen what is this VPC with public and private subnet. We have looked into this also. VPC with public and private subnet and hardware VPN access. This in this particular model, we are accessing private subnet by the help of the VPN, uh, and hardware part is also involved. So in other configuration, VPC with private subnet only. In this configuration, we are only accessing our private subnet, which is present in our VPC through the help of the VPN tunnel, IPsec VPN tunnel. We are using it. So there is a configuration, a tunnel setup interface, and we have a interface in our client side into our organization and in the at the cloud provider, at the site of the cloud provider we have a interface, and in between both of these two interface we create a tunnel that is our VPN access, our IPsec tunnel, and securely we access the private subnet. So in all of these four configuration, this last one is suggested when we want topmost security and confidentiality in our data. So we have studied and seen each and every these. Any doubt, guys? Please drop that into the chat box if you have any doubt. In VPC, what are the different topic in general we're gonna study? There are different topics. Subnets, we have look what are the different subnets. Router tables, we will see what are the route tables and internet gateway. So subnet, private and public subnet, if we want that our instances are accessible through the public internet, then it will be the part of the public subnet. And if we want that our instances are not accessible on public network, then we will add them into our private subnet. Route table basically will consist the rule that will gonna define our subnet and the traffic flow in our subnet. So if we allowed public traffic, then it means we gonna attach this route table in our public subnet so that the public traffic can visit, we can connect and receive public traffic over the internet. That's why we need a route to do that, and we will add that route in our route table. And in the same way, similar way, if we are creating a private subnet, then what we will do, we will not create any public uh, rule for that. We will not allow any public traffic, and we will allow rule only for those traffic. We will create rules only for those traffic uh, on which we want to communicate. Let's say if we want to communicate, if we want to do RDP, our instances that are present in our private subnet, then what will we do? We will allow the RDP rule. If we want other protocols and other communication to be open, other ports to be open, we can allow that, and we can control by the help of the route table also. Then internet gateway. By the help of, sorry, there's a mix up. By the help of the route table, we can control the traffic, where the traffic is hitting, and on which domain and in which subnet the traffic is going, if it can go into the public or not. So internet gateway, if we want that our traffic go out to the internet, then we should have a internet gateway setup. Then we will see what are the different component in internet gateway. We will see the lab also. So for now, let's see these three in detail: subnet, route table, and internet gateway. Okay, subnets. So we all are very familiar with this term. A subnet, it is a range of what? IP addresses. So right now we are talking the subnets in our VPC. So it will show the range of IP addresses that are the part of our VPC subnet. You can launch AWS resources into specified subnet. We can launch EC2 instances. We can launch other services into a specified subnet. Use a public subnet for resources that must be connected to the internet. So if we want that our subnet is a part of internet, and we want some resources that are present in our public subnet, we want that resources to be accessible on internet, then what will we do? We will connect our EC2 instance and our resource with the internet. Okay, a private subnet for resources that won't be connected to the internet. So if we have some resources that don't require any internet connectivity, then we will not connect any internet, and they will be the part of a private subnet. So it is very simple to differentiate two different subnet, private and public. So we will be configuring internet gateway in public subnet. Why? Because we want internet connectivity in our public subnet. Our private subnet will not be going out and communicating over to the public network. That's why no gateway is required over here. So public subnet, if a subnet traffic is routed to an internet gateway, that subnet is known as public subnet. So we have seen this already in our yesterday session. So I'm just giving you a good brief. So when you create VPC, we have seen we have to provide CDR block for our VPC, and we have to do net masking. So there are four. Okay. Do you have a question?
Yeah, so it can be said that any subnet which is having internet gateway that is public and which is not having internet gateway that is private.
Correct. There are different configuration if we want that our private network also have some kind of connectivity. So there is some set of configuration we can do to make that happen, and we will see that in different coming slides. So for now, you are absolutely right. If we have a internet gateway present, then it means that that subnet is a public subnet, and if we don't have an internet gateway, then it's a private subnet because no internet connectivity is there. So we have seen that there are a couple of addresses that is reserved by the AWS. So these first four and last IP address is not in our use. It is used by the AWS, and each and everything is mentioned here. Why it is reserved by the AWS. Some are reserved for the VPC router, some are reserved for the future use, and some are for the DNS services. So let's continue and see what is in the next slide. Route table. Okay. So route table, I have already told you that in the route table we define rules, and these rule will allow us to communicate. So these rule will guide us how our traffic can go out and what kind of traffic we can receive. So you cannot delete the main route table. It is the rule that you cannot delete the main route table. So main route table is our default route table. But you can replace the main route table with a custom table that you have created. So it means that we can create multiple route table, and there is a default route table and we can replace the default route table, but we cannot delete the we cannot delete the default route table, because we are the part when we are using AWS, we are entering in the cloud. So what we mean that whenever we are using any EC2 and whenever we are using any VPC, any kind of service that required a routing facility, route table is going to be present there by default. So that's why default can't be deleted. If we are using VPC, our default will be there. If we are using EC2, our default VPC will be there, a default route will be there. So default table is the route main. And let's understand how we can use tables to define to control the traffic. So let's say I have a router and I have created two subnets in the cloud. In our AWS, I have created two subnets, and I have attached route table A to both of these subnets. So what it means that the rule that are defined in route table A are applied on to the both of the subnet. So whatever rules are written in the route table A are applied automatically on subnet 1, subnet 2. So if I have allowed that traffic can go out onto the internet, the traffic can have that these two subnet can have internet connectivity, then what it mean? Both of these subnet are public subnet, because they are the part of the same single route table. And in this route table, if I have provided a internet gateway and I have accepted the internet connectivity, then both of these subnet will become public subnet. And in case 2, what is happening? I have a one subnet, subnet 1. I have connected this in a route table A. This is my main table. Let's say in this table, I have not provided any internet connectivity rule. I have not allowed any internet connectivity. Then this subnet 1 is my private subnet. Automatically, let's talk about what is happening in subnet 2. So if I have configured a internet gateway in my subnet 2, it will called public subnet because I have an internet connectivity. Simple, guys. Okay, let's come on to the internet gateways. What are the internet gateways? Internet gateway are the internet route, and if any traffic that is hitting internet gateway, it will get away out. Okay, to the internet. An internet gateway is a virtual router that connect a VPC to internet. We have seen these topic yesterday also, but before doing the lab, I want to make sure that each one of you understand, because these are very important topics. Okay, so if you don't if any configuration miss happen, what will happen? Your communication will not go through, and all of the lab is waste. So make sure that you understand each topic and you understand what is the agenda of each component, why we are configuring internet gateway, why we are configuring subnet, why we are configuring VPC, and why there are different types of VPC. So make notes, have your notebook and pen handy with you, and every time you have a doubt, note it out and just make sure you get it clear. And let's continue then. Internet gateway. Our internet gateway is a virtual router that connects a VPC to the internet. Okay, it's a very basic definition. Default VPC is already attached with an internet gateway. There's there are there are some services and some component in the dashboard that we are creating, and some that are present by default. So rather than ignoring the default, if we understand why default is present, we can understand the working. So guys, every time there is a default, understand why it is there. So if we have an internet gateway, then what is why it is there? Internet gateway means that it is acting like a gateway, a barricading between what? There's two sides. So one side is the internet and other side is the site that doesn't have the internet connection, and who our private cloud. our virtual network doesn't have internet connection. So if we provide that internet connection, then it will become a public subnet. And if we don't provide that internet connection, it will become a part of our private cloud. Okay. If you create a new VPC, then you must attach an internet gateway in order to access the internet. Ensure that your subnet route table points to the internet gateway. So if you have an internet gateway, doing proper configuration matter. If your subnet route is not pointing towards your internet gateway, then there is waste of resources. Your traffic is not going out. You will not be able to send traffic and receive traffic. So be conscious and be very, very aware while doing all of this configuration. Don't miss anything out. Okay, so this is a good example, a very simple example. VPC with a public subnet. We have seen it yesterday also. So there is a region and our VPC is created over to a region, and doesn't matter how many availability zone that region has, our VPC is over on all of those regions availability zones, sorry, is over all of those availability zones. So let's say a region has 4 availability zones. So we have our VPC in all of those 4 availability zone. If it has 3, if it has 6, doesn't matter. We create a VPC in a region, not in a specific availability zone. So our VPC is accessible in any availability zone. All the given availability zone, we can access our VPC. Okay. So over here, we have a region and we have created a VPC. And in this VPC, we have 2 availability zone. And in availability zone A, I have created a subnet 1. In my subnet 1, I have an EC2 instance. I happen to have a EC2 instance running with a private IPv4 address and elastic, that is a static IPv4 address. So this is what I have issued. And there's a router attached, a internet gateway attached. What is the ID of internet gateway? I am zooming in, guys. You can see over here. In this router, this is the custom route table add. If this table, I have created this table, then what it means that my subnet, sorry, my EC2 instance can communicate locally onto this subnet mask, which is 10.0.0./16. So this is my local subnet, and my internet gateway is this one, 0.0.0/0. So my local and my internet gateway is now configured, and I have attached this route table in my router. So I have done the configuration. This is we call mapping, and it is very necessary, guys, that before doing the actual configuration, you really map each and everything out, your each and every step, because by while doing it on paper, you will remember the step wise guide. So you just have to follow the step. Otherwise, if you do direct configurations, there are some chances that somehow you will miss some step, and going back onto the step is very, very difficult, because there is no proper layout. Everything is in your mind, and by your hunch you are doing the configuration. So if you miss one step, you don't know which step you miss, and going back to that step is very difficult. That's why doing mapping is very, very important. Now, VPC with 2 public subnet. What we mean when we talk about VPC with 2 public subnet? I have a region. There is a default VPC, and I have 2 availability zone in which I have created 2 subnets, and those subnets I have connected with this internet gateway, this router, and this router is connected with the internet gateway. Okay, so both of these subnet has connectivity with each other and with the internet. Why? Because I have given the internet gateway to it. So you can see I am zooming in over here. This is the route table. This is what the route table looks like. Destination and target, it is given to you, and your gateway ID is also added. You can see both of this subnet are part of the same table group, same route table. We have seen this picture before. So this is a elaboration of this one. Okay. VPC configuration with public and private subnet. So we don't have to do nothing extra. We just have to create another route table, and in that route table we will only allow the local traffic. We will not allow any internet gateway, any traffic to go out on the internet, and we will not receive any traffic also from the internet, because no internet gateway is present. So in this diagram, we have two subnet in different region, and multiple instances are running in each of these subnets. And both of these subnet are connected with the router. But in subnet 1, route table A, uh, telling us that the subnet has the connectivity with the internet gateway and with the local subnet. So subnet 1 can communicate with the subnet 2, and it also can communicate with internet. But in the route table of subnet 2, what we see that only local traffic is allowed. I can only communicate with this subnet, which is 10.0.0/16. And so this is the visual representation and mapping. Now let's understand. Okay, in some scenario we do want to have our private subnet to be a part of internet. Maybe we don't want that anyone from internet to visit our private subnet, but we do want that our private subnet have a internet connectivity, maybe to download uploads, to download patches, to download newer version of applications. So there are different regions, there are different reasons we can want that our private subnet also have some internet connectivity. Okay, so what can we do in those kind of scenario? There are some important point also, we will discuss them later. But before, let understand how we can have internet connectivity. So now you guys will be thinking, well, then we can attach the gateway. But we if we attach the internet gateway, we can uh, receive traffic, we can send traffic, but anyone from the outside, anyone from the internet and anyone from the public can come into our network also because of that gateway, right? We are setting the gateway because we want that public also visiting our instances and our subnet. That's why we are configuring the. Okay, do you have a question?
Yeah, it means internet gateway is always two-way, right?
Yes, it is two-way, and we have some configuration in that internet gateway also, but it going to be two-way only. We can allow different kind of traffic, we can allow different kind of subnets, and we can allow different part of the network we want to connect to. But yeah, they're going to be two-way. Anything else, guys? Okay, so net gateway, when we have internet gateway we have two-way connectivity, but we don't want that anyone from the public internet come and visit our private subnet. So what will we do? We will configure a net gateway. And why the net gateway? We can communicate with the internet, we can go and visit the internet, but no one from the internet can come in. So traffic can go out. Inbound is allowed, but outbound access will be denied. So let's see what is the deal with internet gateway. You can use a network address translation gateway to enable instance in a private subnet to connect to the internet or other AWS services. So net gateway enable us to connect with internet. How? But prevent the internet from initiating a connection from those instances. So if you have initiated the communication, let's say I am sitting in a private subnet, and that subnet has a net gateway connectivity, then what will happen? If I want to visit YouTube, I will be able to visit YouTube. But someone from the internet, like someone who is sitting out on the internet and just like want to send me a message over to my computer, will they be able to send me the message? No, they will not be able to connect with me, because my net gateway allows me to initiate the communication and receive the answers and receive the connection back. If I am asking for certain documents, all the document I want, I will receive them. But any initiation for conversation, any initiation for some kind of sharing will not be allowed. Okay, that will be discarded. If you want EC2 instances in a private subnet of a virtual private cloud to communicate securely over to internet for things like software update and package download, we we were just discussing this, why we want net gateway, why we want the internet connectivity to download some software updates, to download some uploads, to download some package, to download some patch, some anything, if we want to go and have an active connectivity. But we do want some security also. That's why we don't want any outsider to come inside our network. That's why net gateway is our option. But if we want that public traffic can come in, all can also come in, then internet gateway. Okay, so that's the difference. Don't get confused, guys. Okay, you are charged for creating and using a internet gateway in your account. So this service is chargeable, internet net gateway. So it's not a part of free tier. Hourly, you will get charges. Net gateway hourly use and data processing rate apply. Amazon EC2 charges of the for charges for data transfer also. So whatever data you are transferring through your net gateway, and whatever hours, for like there's a certain period of hour you are using your net gateway, the according to that you will get charged. Sorry. To create a net gateway, you must specify the public subnet in which the net gateway should reside. So make sure you understand why net gateway is reside inside the public subnet. Can anyone tell me the why it is a part of public gateway, public subnet? Why not private? I'm asking, guys, when we configure net gateway, we attach that net gateway. We generally put that net gateway in public subnet. Why not in private subnet? We are configuring net gateway for our private subnet. We want our private subnet to have connectivity. Then why we are putting this net gateway in public if we want connectivity for our private, and we can achieve that with net gateway? Why then this net gateway is in the public subnet? Any guesses, guys?
Yeah. Because in public only we can connect to internet, no?
Yes, yes, absolutely right. So wonderful. Uh, that's why net gateway are in the public subnet because they don't have internet connectivity. What are, guys, why this point is important? If someone asks you what is the difference between net gateway and internet gateway has internet connectivity, a route to internet, but net gateway has a route to internet gateway. Okay, guys. So we will configure our private subnet. We will add a route to net gateway in our private subnet. Then in our net gateway, we will attach a internet gateway, and net gateway will be sending the traffic out to the internet gateway. Then why there is a net gateway? Net gateway is acting like a barricade. It is acting like a stopper. What it will do? It will allow traffic out, but it will not allow traffic in. It will not allow any connection from the outside to connect to our private subnet. It will discard it. Okay. So you must also specify an elastic IP to associate with the net gateway when you create it. You need to okay, so net gateway require elastic IP. Then we will see elastic IP topic also. So no need to assign public IP address to your private instances. Obviously, when we are creating instances, when we are setting up our EC2 in our private subnet, then if they don't have any public IP, it doesn't matter and it doesn't require, because we don't want any one from the public to acquire to access our private instances, which are the part of our private network. So they won't be having any public IP. If you want them to have any public IP, you can allow them to have public IP, but they are of no use because no connectivity is allowed, because they are the part of private network. Okay. Net gateway. Again, let's continue. What are the other things also are the part of this net gateway? After you have created a net gateway, you must update the route table associated with one or more of your private subnet to point internet bound traffic to the net gateway. So this enables instances in your private subnet to communicate with the internet. So it is telling us after we create the net gateway, we have to update route table with the private subnet to the uh, private subnet to the point internet bound traffic to the net gateway. So whatever traffic we want to send out to the internet, we have to do the configuration that that traffic will hit the net gateway, and through the help of the net gateway, that traffic will further go to the internet gateway, then route it towards the internet and out of the cloud. You have you have a limit on the number of net gateways you can create in an availability zone. So there is a limited number. You If you no longer need net gateway, you can delete it. Deleting a net gateway disassociated elastic IP address, but does not release the address from your account. So elastic IP is required for the net gateway. We want a fixed IP, a static IP for our net gateway, because whenever we are sending our traffic out from our public subnet, we want that to be secure and we want that to be very stable. That's why we want a singular IP to hit every time if we want any traffic to route out towards the internet. That's why we want the elastic IP. And when we delete our net gateway, the elastic IP that is attached with our net gateway will get detached. but it will still under our possession. We still have a elastic IP. Elastic IP will not get deleted. So we have to delete the elastic IP differently. So make sure, guys, elastic IP, if it is not attached with any service, it will cost you. So that's why I have mentioned this point. So whenever there is a case of elastic IP, make sure that it is attached with a running service, not with the stop one. If it is attached with the stopped service, it will still cost you. Elastic IP is attached with the running service, and if you are not using it, then delete your IP. Release your elastic IP. Okay, architecture of VPN with the net gateway. So we will do this lab, and what will we do in this lab? Let me show you the following diagram illustration. The architecture of VPC with a net gateway, the main route sending internet traffic from the instances into the private subnet to the net gateway, and the net gateway sends the traffic to internet gateway using the net gateway's elastic IP traffic at source IP address. So this is just this illustration is showing you the way of traffic in and out. So let me just show you by the help of the illustration. Okay. So we have a region, let's say this is our Mumbai region, and we have two zone availability zone present in our Mumbai region, and in one no three zone, we have three zone in Mumbai region, and in one of this availability zone, I have created two subnet in one availability zone, public and private. In my public subnet, I have few EC2 instances running, and they are connected with the router. And in my private subnet, I have few instances running with private IP. You can see their IP is private, and they are connected with the router also. So let's see their route tables. For my public subnet, my route table says that the local traffic for 10.0.0.0/16 is allowed, and internet traffic for 0.0.0.0/0 internet gateway ID is attached. So my internet connectivity is available for my public subnet. Okay. For my private subnet, what is my route table is telling me? My destination, where I can go anywhere in 10.0.0.0/16 subnet, because it is my local subnet. And if I have any other traffic, 0.0, any other traffic for any other domain, it will go to my net gateway. Okay, it will go to my net gateway. Then what will happen? If I have a traffic, it will travel to the router, and router will it will go to the router. Router will lead it to the net gateway, and from the net gateway, it will come back to the router and route it towards the internet gateway. Okay. The following diagram illustrates that architecture of VPC with a net gateway. The main route table send internet traffic from instances. So the main route table, whatever route table we are attaching with our subnets, will direct the flow of traffic from our instances in our subnet. So in our private subnet, the instance in the private subnet to the net gateway. The net gateway sends the traffic to the internet gateway using net gateway elastic IP address as the source IP address. So my public IP address will not go out. What will go out as the source IP? Net gateway's elastic IP, which we have given to the net gateway. Okay. So if I have configured a net gateway, what will happen? For any traffic, for any route, for any subnet, okay, for any network, for any network, they will hit the net gateway. If I want to send traffic out, any kind of traffic to any gateway, sorry, any kind of traffic to any network, what will happen? I will send it to the net gateway. What will net gateway do? Net gateway will attach its IP address and send the traffic out and receive the response. If I am asking for some file, it will receive the response, receive the package that contains the file component. But if someone is trying to contact me from the outside, it only have the net gateway's traffic, and net gateway will not respond it. Okay, please guys tell me if you have any doubt. Okay, guys, we have very few participants today, only five, and we are like I have shown you VPC, I have shown you Net Gateway. So let's do one thing. We will do the lab tomorrow because very few participants are there. Let's see if the strength is same tomorrow also, then we will not wait for anyone, but let's wait for others before we go on and do the lab. Okay. Bec- so a- any doubt, you can let me know in like any topic, whatever we have covered, all of the things we have covered till now. Let me know if you have any doubt in any topic. Not only in today's topic, anything till now, like from the very beginning of this training. Any doubt? Yes, actually, I got the access to the videos. I just have to attach them with the name and with the presentation, like what are the topic are in this particular day and what topic we have covered in this particular day. So I just have to attach some information with the recordings, and I will send you the recordings, and you can watch it out. And for the PPT, I can send you the PPT, and you can ask from the management. So I will share the PPT, and if you want, you can capture the slide from the recording as well. So you can do that. Okay. So guys, we have covered a lot of things till now, and we have seen many different aspect of AWS, and we have seen different things in AWS. And till now we have seen two major service of AWS: EC2 instances and VPC. And we have uh, came very far, and till now, if any doubt, I am showing you all the slides we have seen until now. So I am just going back and forth. So if any topic that's click you, that you have doubt in, that you can let me know. And otherwise, to for today we have like we I will suggest we don't go further because we don't have any. Okay, because of lack of participants. Okay, if you want that, you want me to recall any particular topic, we still have like we are still on clock, so we still have some time left. So if you want detailed description, if you want any overview again on any topic, just let me know, guys. Okay, then let me just give you a recap what we have done today. So we have seen VPC. In VPC, we have seen subnets, route tables, internet gateway, and NAT gateway. This one, NAT gateway. So we have seen four things. Afterwards, we will see DHCP option set. So we know what is the DHCP, elastic IP we have seen. Endpoints, peering connection. This topic is also very important. Virtual private gateway and customer gateway. So these are our coming topic, but before going on to these topic, we will do the lab. A lab of we will configure subnet, we will provide route tables, we will attach internet gateway, we will attach net gateway. So we will do that lab tomorrow. And what is the architecture of our lab testing? It's this. What will we test in our lab? We can ping any website from our private instances. So when we will give a net gateway attachment to our private instance, what it will mean that we have a internet connectivity, and with our internet connectivity we can visit any website. So we will try to ping some website with our private instance. Can we trace it route to internet? We will try to trace route out to our internet. We will try the tracer command. What will happen with our tracer command? We will see what is the source IP address to our coming packages. Okay, then what you can check private instance is available from outside or not. Then we will try to RDP our private instance. Okay, only thing that is left to check out is slide. And where it go? Wait a second, please. Here, important points to discuss. So we will see the billing dashboard when we will do the lab. And we will receive the 8 hour alerts. So there's a setting. So I will show you to make sure that every one of you have your alerts on, so you guys won't miss any alerts. If you miss it, what will happen if any service is remained unchecked by you, and it is a chargeable service, what will happen? You will get a charge against your debit or credit card, whatever you have attached. So it is very important to switch on these alert. Whatever notification you will have, you will get an alert, and you can take a action against that. Just terminate everything before from your region after getting practice. Uh, Sometime, guys, we are working in different region. What happen, we forget in what region we are working, and what are the different services, and what are the different services we have installed. So make sure that you go into your global desktop and check out what are the different region, and terminate everything from every region. Make sure you select from your region in which, okay, same thing. Then VPC pricing. So pricing, there is a structure of VPC pricing. We have seen different VPCs with public subnets, with public and private subnets. We have seen public, private with VPN hardware. We have seen only private with VPN. So we have seen different implementation of VPCs. Then there are different pricing schema for all of these services. So we will see what are the different prices, and what are the service we can use in our free tier, and charges we will see. So for now, like for today, I think we have done enough, and we will do the lab tomorrow. And guys, be present, and just like I am scheduling the lab tomorrow. We have to do the lab today for VPC, but I have done theory because we have very less strength. So for tomorrow, we will check if we have the same strength, then we will do the lab, and let's hope that we get more participants. So otherwise, the student will not be updated with the course, and they will have to go through with the recordings. So this will create a option for doubt, because when you are getting the live class, then you can ask the doubt simultaneously, and the doubt will get clear. Otherwise, when you are watching recording, the doubt will get stuck and your focus will be divided now onto the recording, onto the teaching, onto the slides, and onto the doubt also, because you're continuously thinking about how to solve it. So it is better to join the live session rather than depending on to the recordings. So let's do the lab tomorrow, guys, and you do the practice. Do one thing, do EC2 practice, and if you face any configuration difficulty, just let me know. Thank you, guys, and that's all for today. You guys can leave the meetings.
Thank you.